Hey everyone, Miss Soli here with another lesson in Unit 3. This one is exponential modeling. So what does this have to do with the real world? What does this have to do with the real world? Okay, so we're going to go through a couple of pretty common situations. Modeling. With exponential functions. Reminder, my exponential function, f of x equals a times b to the x. But when I'm dealing with real life situations, I often have like a rate of increase or a rate of decrease. And it's a little bit trickier because it's kind of a part of b. 1 plus r is going to be if your situation is growing. So R would be your growth rate. And that growth rate has to be in decimal form. So a percentage in decimal form. Real quick, how to remembering how to do that. So if like my growth rate was 12%, for example, then R would be move the decimal 2 places or divide by 100%, because 12% means 12 out of 100. So 12 divided by 100 is 0.12. So your rate has to be a decimal point. Also, like 5%, if it's a number less than 10, 5 divided by 100 is 0.05. So you have to move that decimal point 2 places. Okay, so let's have an example. Let's say a population of a town is 5,000 people, and it grows by 15% each year. So I want you to write an equation for this city's growth rate and then find what will the population be? Estimate the population in 5 years. In 5 years. Okay, so first I'm going to write my equation, right? We need an A and an R. So your initial population when we're starting this equation is going to be 5,000. And then your rate, 15% as a decimal is 0.15. So let's plug that in. F of x is 5,000, 1 plus 0.15 to the x. Sometimes some textbooks put this as t for time, because often exponential is looking at over the course of time. How did it grow? How did it shrink? Whatever. So let's simplify this a little bit. In parentheses, 1 plus 0.15. 5,000 times 1.15 to the x. This would be like in this top form, a times b to the x. This is it. So my growth ratio or common ratio is 1.15. So this is it. This is your equation. Then it asked me to estimate the population in 5 years. Now, of course, it's not going to be exactly accurate. It's just an estimation. A lot of real things happen when I'm estimating population. But with these kind of exponential modelings, you can usually get pretty close. 1.15 raised to the 5. Remember, with PEMDAS, I always need to do my exponent first. So I really like to do this kind of separately. I'll do 1.15 raised to the 5 enter, and then multiply that times 5,000. So it's estimated that this town will have 10,050. It says 6.7. Can you have 0.7 of a human? But because the 7 is above 5, let's round that up to 7 people. Okay. Now let's take a look at a decrease. So this is called exponential growth. What it would look like if something is decreasing. Either a population in a town is decreasing, or we're going to talk about it in terms of like views on a video. So if it is decreasing or decay, the function is not much different. Still f of x equals a times 1, but instead of plus a rate, minus a rate. So when you're looking at a situation, you just have to really be careful of is it growing or is it shrinking? So then it'll determine which equation to use. Okay, so let's say I've got my video views on day 1, or I guess day 0, the day that you post it, is 8,192. And then it decreases 25% each day. Because generally with video views on like TikTok or Instagram, you get a lot of views on the first day, and then it will show less people will see it as each day continues. So my question is, how many people estimate how many views on day 10? And also, when will zero people view it? All right, so let's write our equation. So A is equal to my initial 8,192. Your rate, remember, not 25%, but 0.25, write it as a decimal. So if I were to plug these in to my decay function, 8,192 times 1 minus 0.25 to the x. Simplify this a little bit. 8,192 times 0.75 to the x. So this number in a decay will always be less than 1. So let's do the first question. The first question is, how many views on day 10? F of x is, f of 10, 0.75 to the 10th. So again, be careful of PEMDAS, right? First, I'm going to take 0.75 raised to the 10, and then I'm going to multiply that by 8,192. 461. This 3 isn't big enough to round it up, and I can't have 0.3 of a views on day 10. Now, when will it be 0? So this is something that in later years, or I think later chapters actually, we'll get some more tools to figure out. But for here, it is just going to be kind of a guess and check. So we know it is going to be more than 10 days, because I still had 461 days on day 10. So let's just kind of plug in some other numbers and see if I can get closer to 0. So let's see, if I plug in 20. So if I plug in 20, I'm going to get, there we go, 0.75 raised to the 20 times 8,192. Ooh, 26 views. It's getting much lower. Okay, let's see. Let's plug in 30 times 8,192. Oh, dang. 1. Oh my gosh, lucky. 1.4. So it's still 1. That's still 1 view. So let's try 31.75 raised to the 31 times 8,192. Oh, I did it again. Oh, still 1. Let's do 35.75 raised to the 35. 0.3. Okay. So between days 31 and 35, let's just double check. Raised to the 34 is still 0 and 0.4. Let's see, 0.75 raised to the 33. There we go. Okay. 33 is 0.6. The 6 would round this up. So my answer is day 34. I would have 0 views. And of course, like this is also just a prediction and anything could happen online. Like maybe you could, I don't know, whatever could happen. So like this isn't always accurate, but this is an estimate of what could happen. Another really common use for exponential modeling is like the value of a car. So when you buy a car, it will decrease in value each year. So this is a very common thing to look at when you're purchasing a car is what's the depreciation rate? So how much will that car lose its value each year? Something to always consider.